Hey, what's up everybody? Going over a test, spring 2021, test number 1. We're going over linear programming, graphing systems of inequalities, linear inequalities. We're also solving matrices, solving systems of equations using matrices. What else are we doing? Things like that, equilibrium points, etc., stuff like that, maybe the break-even point. Different types of questions. Question number 1, a bicycle shop estimates the demand equation for its newest bike is that price equation, price and demand. X is the demand, P is the price. Let's see the supply equation. So we have the demand equation and the supply equation. Okay, we have two equations. It wants us to find the equilibrium. The equilibrium occurs when the price of the bike is. Okay, so we're gonna find the equilibrium price. So for that, we can solve the system of equations. That's pretty much it. So we can go to Desmos. Let's see, calculator. So how about, okay, P equals negative 12x plus 787. P equals negative 12x plus 787. We also have P equals to 14.5x plus 469. 14.5x plus 469. Now with that system, what I can do is I could set the p's equal to each other and do this. Negative 12x plus 787 equals to 14.5x plus 469. See that? How we can set them equal to each other, and then from there we can subtract. So we can actually add 12 to both sides to get 787 equals to let's see, so I'm adding 12, so I get 26.5x plus 469. Okay, so far we're right here. This is our equation right now. Notice that I added 12x to both sides. Added 12x. Okay, anyway, if I subtract 469, I do like 787 minus 469, I get 318. So far I have, what do I have? I have, negative 318 equals to 26.5x. So then my last step, I'd have to divide, right? Negative 318 divided by 26.5, and I get negative 12. Oh, look at that. Okay, so I'm gonna say x equals negative 12. So that's my x value. Well, good. This asks for price though. This thing asks for price. Make sure you show your work on the test. How could you show your work? Well, you could try to copy this, come to the test, press insert, equation, go to the advanced, and then press Control V and press insert equation, and it puts it in there. Look at that. X equals 12. That's amazing. How nice is that? Now I wonder if I can make it. No, I can't make the font bigger because it won't get wider. Anyway, now that's just the x value, right? Well, I need the p, so I could go back here and say, just grab one of these, right? Maybe I'll grab this side. Control C, press Control V, and I'll change this x to negative 12. So times negative 12. And that gives me 931. So I could say P equals that, which equals 931. And then just copy that, Control C, go over here, press insert equation. We could try in the basic. It worked in basic this time, so that works too. So there we go. So equilibrium occurs when the price of the bike is 931. That's it. Okay, number 2. Solve using matrices. Okay, I'm gonna show you guys how to solve a system of equations using matrices. This is how you do it. 1, 1, 1. Vertical bar 2. That's my first row. If you press shift and enter, it puts it close, but if I press enter, it leaves a big space. Tip, shift enter. Okay, 4, 3, 2, bar, and then 0. I mean, it's better to do this on paper, but I'm gonna show you how to show your work on Canvas, assuming you're taking the test in a pandemic. and you can't show your work. So that's the first matrix. Okay, so I'm gonna do this, shift enter. I'm gonna put a, actually, you know what? I'm gonna do this. I'm gonna go to the right. I'll put a new matrix. My second matrix, 1, 1, 1, vertical bar 2. Oops, I pressed tab. Not a good idea. Can't use tab actually here. Okay, now I'm gonna multiply -4 times. Now, so here you do your side work and you try to get this 0. So you do your side work and you get 0. I could actually do it in my head. -4 times 1 is -4 plus 3 is -1. But you would do this on the side. So -4 and 2 is -2. Vertical bar, -4 times 2 is -8. So -8 and 0 is -8. For this one, I'm gonna do +3 times 1. I'm gonna get my 0. +3 and 1 is 4. +3 and -1 is 2. Vertical bar. +3 times, that's 6 plus 2 is 8. Okay, so that's my second matrix. Now I'll go to my third matrix. A 1, 1, 1, vertical bar 2. 0, oops. 0, -1, -2, vertical bar, -8. I could have made those positive, by the way, because they're all negative, so I could just change the sign. Okay, now I want to multiply the second row. I want to, you know, to get rid of this 4 right here, I can multiply the second row by +4. So I'm going to do that, and I'm going to get 0, 0. So +4 times -2 is -8. -8 and 2 is 6. Gotta be careful. Let's see. So +4, that's -32. -32 and +8, what's that? -24. It's tough to do all this in your head, but okay, I'm done with the matrix. So now I can do my next step. I can say 6z equals -24, which tells me that z equals to -4. Good. Now I could do -y. By the way, I'll just make that second row all positive. So y plus 2 times -4 equals to 8. See, I can multiply that second row. I can multiply all these numbers by -1. So basically all those could be positive to make my life easier. To make all of our lives easier, right? So from this I get y equals 2. So that's -8. So do I get 16? Something seems wrong. I get 16? I didn't know that. I thought that was, for some reason that doesn't seem right. Let me see, let me think. +3, 4, that's 2. So, okay, 8, so I multiply by +4, -8. This should be -6 maybe? I think I found my mistake. Because +4 is -8. -8 and 2 is -6. I think I found my mistake. Yay. So z equals +4. Okay. That's better because I thought that y was 0. So y is 0. Okay. Ooh, close call there. So then x plus 0 plus 4 equals to 2. That tells me that x equals -2. So I get my answer, which is -2, 0, 4. Woo! Yay! We did it. We did it. Now you can check your answer, highly recommended, in the following way. So -2 and negative times -3 is +6. And then plus 0, so I got +6 so far, and then a -4. So +6 minus 4 is 2. Hey, this works on the last equation. You can check the top equation is the easiest to check. So -2 and 4 is 2. Yes, that works. So that is correct. This answer is correct. You see how you can check your answer? Now this is how you show your work on the exam. Bad idea. I wanted to do these. Better idea. Okay, that's it. So there you go. All right, next question. Solve the system of equations if possible. Blah, blah, blah. Another question. Now for this one, I may want to put this bottom equation on the top. I may want to say 1, -1, 1, vertical bar, 0. And oops, and then I'll say 2, 1, -3, 0. And then I'll press shift enter to get it nice like that. And then I'll say 4, 2, -6, vertical bar, then 0. Hey, I did my matrix. I've never done this before, typed matrices before this semester, but hey, we're trying to be innovative here. So look, 1, -1, 1, vertical bar, 0. Come down here and we'll do our magic. Let's see. So -1 times 2 is, now this is what you guys would do on paper, but I'm doing it in my head. -2 and 2 is 0. -2 is +2, so it's 3. -2 is -5. This is kind of how I learned how to do it as a kid when I was in school. We basically did it in our head. I didn't show my work. So -4, 4 is 0. +4, 2, that's 6. This is tricky. Negative, I don't recommend this. -4, -6 is -10. I'd rather show my work. It's less error prone if you show your work here on your side work. But 1, -1, 1, vertical bar, 0. So 0, I'm just repeating my second 2 lines. I'm just copying them. I don't do anything with my first 2 lines, I mean. So now this is the line where I need to make another 0. I want this 6 to be 0. So then, okay, I multiply the top equation by -2 and then add it to the third equation. So 0, 0. So -2 and 5 times 5 is +10, so I get another 0. How am I doing on time? I'm okay. And then I get 0. Hey, I get a row of zeros. That's kind of not good for you guys, because that means infinite solutions. Let z equal t, and then now you just say 3y minus 5t equals 0. That tells us that 3y equals to 5t, which tells us that y equals to 5 over 3t. And then to find x, you say x minus, ooh, this is gonna be hard, 5 over 3 t plus t equals to 0. If I multiply both sides by 3, I get 3x minus 5t plus 3t equals 0. Okay, that means 3x equals to 2t, and then that means x equals to 2 over 3t, giving us the final answer of 2 over 3t comma 5 over 3t comma t. Now you should check that. Let's try to check it. Let's see if it works. You know that you can always check your answer. How do you check your answer? Just try to make sure it solves one of the equations. Let's try the top equation. 2 times x, which is 2 over 3t, plus 5 over 3t minus 3 times t should be equal to 0. Let's see if it equals 0. You get 4 over 3t plus 5 over 3t minus 9 over 3t, which equals to 0. Because 5 plus 4 is 9, minus 9. Yeah. This is my check, by the way. This you don't have to do. You do not have to do this. I'm doing it just to check my work because I want to make sure it's correct. And you guys, you could do that. It's recommended. Hey, why not? See if you're correct. But anyways, this is the answer right here, and that's how you show your work. Okay, question number 4. Give me the corners for the following system of inequalities. Show some work on how you got the ordered pairs. Alright, this is a system of inequalities. I have a hard time doing this online. I would need to get my iPad out, and I don't want to get my iPad out right now, so I'm just going to show you what they are. So look, here is a picture of these inequalities. Here's the top inequality. It's greater than, so it goes up. It's red, it's shaded up. Here's the bottom equation. It is shaded down because it's blue. It's so where is all the shading going? Here. See this? So that's a point. What's that point? 0, 8, 2, 4, and 0, 2. So let me write those corners down. So the corners, so we drew, I mean, I can't do this right now because I'm on my computer, but we drew the feasible region and we drew the system of inequalities and found the feasible region with corners, what were they, 0, 2, 0, 8, and we we found the corners. 0, 2, 0, 8 are just y-intercepts, so they don't require work. Those are just can be observed. We don't need to do work for those. But 2, 4, the last corner, we find by solving. Negative x plus y equals to 2 and 2x plus y equals to 8. So for that I could do substitution, right? I could say y equals 2 plus x, plug in. So I get 2x plus 2 plus 2 plus x equals 8. So what I'm doing is I am substituting into this equation 2x plus y equals 8. Alright, I'm gonna scroll up so we can get a better view here. So we get 2x plus 2 plus x equals to 8, just algebra here. So that means we have 3x plus 2 equals 8, which means 3x equals to 6. Hey, that looks good. X equals 2. If x equals 2, then we can get y equals 2 plus 2, which equals 4, and we're very happy because we get 2, 4 as our last corner. And those are the answers. So these are the answers. I can make that yellow. And then these. So there are 3 corners, which is reflected on this graph. 1, 2, and up here, 3 corners. This is the feasible region. This is this triangle right here. Next question. Set up the objective function and the constraints, but do not solve. Jack has a casserole and a salad dinner. Each serving of casserole contains 210 calories. Okay, 4 milligrams of vitamins, 7 grams of protein. That's the casserole. Each serving of salad. Okay, so we got casserole and salad. I mean, they kind of made this one easy. They said let X represent the number of servings of casserole, Y the number of servings of salad, and C the number of calories. They kind of helped you on this question by defining the variables for you. So here is what I'm gonna do. Look, Jack wants to consume at least 24 milligrams of vitamins. Okay, watch, vitamins. At least 24 milligrams of vitamins. How many servings of each food should he eat? We got X and Y. As far as the vitamins go, they go 4X because the casserole has 4 milligrams of vitamins, so we could say 4X plus, and then for the salad we have 7 milligrams of vitamins, so 7Y. And it says he wants how many vitamins? He wants a lot of vitamins. How many? At least, that's an important, at least 24 milligrams of vitamins. So okay, at least tells us we should do greater than or equal to 24. So that's one of our constraints. Another constraint has to do with the 28 grams of protein. He wants 28 grams of protein, but at least. So protein. How's protein looking? Well, 7 grams of protein for the casserole. Okay, so 7x plus how many grams of protein in the salad? Probably not much. 1 gram of protein, so plus y is greater than, and how many does he want of protein? He wants 28. He wants 28 grams of protein. Cool. Lastly, we need to do something with the calories. That will be our objective function. Objective function. Well, we can use C equals to 210. I'm looking at the 210x because I see 210 for the calories. I also see, what do I see for the solid? 50. Cool, so we're done. Plus 50y. Oh, I forgot one thing. It's always good to do the following if you want to get full credit. You should always do this. X greater than or equal to 0, comma y greater than or equal to 0. You should always do that, right? Because you cannot consume negative amounts of salad or casserole. And that's it. So next question, moving on through. Hey, are we almost done? Well, this is a short test, very short test. Find the maximum value of the objective function subject to the following constraints. Shoot. For this question, we have to graph it. Okay. All right. For this question, we need to find the maximum value according to these constraints. All right. Well, I can't do this on my iPad. I mean, I guess I can, but I'd have to log in. I'm making this video from my computer though. So what I'm gonna do is I'm just gonna look at this graph right here, and we can tell from this graph that this. We kind of should zoom in maybe, but down here is not the feasible region. It's up here. Here's where all the arrows would point within this little thing here, this little triangle here. So these two are y-intercepts, so these zeros are easy to get, right? 0.27 and 0.35. So we get, so draw and you get two corners on the y-axis, which are 0.27 and 0.35. The last corner is found by solving. 5x plus y equals to 35, and 6x plus 2y equals to 54. So we could do y equals 2. If I scroll up, we could say y equals to 35 minus 5x, and then we substitute that in to the other equations. So 6x plus 2 times 35 minus 5x equals to 54. Now we gotta start combining like terms and distributing the 2. So plus 70 minus 10x equals to 54. Let's see what's up here. Okay, negative 4x equals to, because 6x minus 10x is negative 4x, and then 54 and 70, what's the difference? 16. So negative 16. Ooh, that's good. We get x equals to 4. Nice number. So then that means y equals to 35 minus 20, because 5 times 4, right? It's 20, so 35, so that's equal to 15. So we get our last quarter of 4 comma 15. We have 3 corners. We got these two. We got this one. Now, how do we find the maximum value? We got to plug them all in, and we got to show our work. So we say z equals to, what was our objective function? Oh, there it is. 16x plus 5y. So 16x plus 5y. Well, I'm not even going to plug in 0.27 because it's a waste of time. And I'll talk about that in a second. But 16x plus 5y, so 5 times 35. So 5 times 35, that's 150 plus 25. What's that, 175? Okay, so that's one of them. And then the other one, so notice how I don't need to plug in 0.27 because it's smaller than 0.35. So I know that 0.27 is not going to be my maximum. I know it because this one has a bigger y value. My last value to consider is 415. So I'm going to say 16 times 4 plus 5 times 15. If I do that, I get 40 plus 24 is 64. And then 50 and 75, 64 and 75, that's 139, maybe 139, could be wrong, but that's not the max. Looks like 175 is the max. We got it. We got the max right there. So we say max equals 175, and it occurs at 0.35. And that is the end. So that's how we do this test. That's how you show your work. All right, hope that helps.
It's time to go.